Good evening, ladies and gentlemen. Welcome to the first meeting of the SPR this year. We are looking forward to another wonderful year, and we are off to what I'd say is a very good start. When I first met Dr. Duan, I realized that he had something immensely interesting and important, but no doubt difficult to tell us. And so I was delighted when he accepted the invitation to give us a lecture. Our details of Dr. Duan on the table outside, maybe some of you have seen that. He was born in China. He came to the UK and he completed or gained a PhD in material science at Cambridge. And he has since then been busy in that general area. He keeps official contact with China, and he is also a vice president of the Chinese Parapsychological Association. We have a very distinguished person to start us off this year, and without taking any more of his time, Dr. Duan, would you talk us about Metacomputics, which I must say is a term which I'm not familiar with. I hope by the end of the evening we all will be. Thank you.
Thanks, John, for the kind introduction. Thanks, everyone, for making the efforts to come to join me tonight. It's my belief psychic phenomena is as old as human civilization. But it was actually SPR who made the scientific approach, started the scientific approach, rational approach to this phenomena. So I think it's monumental contribution to the human civilization. Actually, look at the phenomena rationally, scientifically, by scientists. Yeah, so it's a great place to be. I really feel at home today. It's like coming home because I have scientific background. I have a passion to look into this phenomena seriously. So yeah, thanks again for coming to share this talk. Today's topic is trying to make sense of psi. Yeah. One way to define psi is actually paranormal phenomena which cannot be accounted for by physics. That's one of the definitions. So therefore, if you want to make sense of the phenomena, you cannot really make sense using physics by definition. So we have to try a different approach. And that approach has to unite consciousness, mind, and matter all together. And that approach, so I have been sort of trying to develop a model using that approach. This approach, I call it Metacomputics. It's still early days. I am actually at the stage where I began to share with people and try to get feedbacks, comments, suggestions, so we can develop further. It's a big topic. It's not somebody, one person can handle it. So it's a great opportunity to have you here with me. Thanks for your time. To make sense of anything, let's briefly to review how we actually make sense of unknown, for example. How we human actually deal with things unknown. Yeah. If you look at the history, we actually need conceptual tools to make sense of the world. Without concept, we cannot understand anything. If you're a blind person, you need concepts like a pillar, like a rope, like fan, to make sense of an elephant. Without those concepts, we cannot understand anything. So we use a lot of this approach to understand the universe also as a scientist. Yeah. What we need to know is that those concepts evolve in time. Okay? So in mechanicals time, in Newton's time, our understanding of the universe is a machine. It's a clockwork-like machine. Yeah, you can determine everything by mechanics. Yeah, that's the model we use because at that time we use machinery. When the human society was electrified, we have a concept of electricity. So we use electricity as a concept to understand the world. So we come up with the idea of charged particles. So it is electric charged particles to make sense of the world. And we build models based on electricity as a concept tool. Nowadays, we are in another era. And this era is called digital age. Okay? So in digital age, information age, we have new concept tools we can use. And those tools can help with us to make sense of the world in a new way. Yeah. So nowadays, we are exposed to concepts like this. Computer, big data, cloud computing, virtual reality. Those are new concept tools. It makes life more interesting, actually. So I'll briefly go through some important concepts because they are very fundamental, very important to understand. Computer fundamentally is actually very simple. It's actually only two opposing states. Yeah, very simple, on and off. So the input is on and off. It's like a switch. And output is also on a switch, on and off switch. It's very simple. Yeah. So polar opposites, which interacts, which interchange, make the machine computing. Yeah, of course you can connect it into different logic circuits, but fundamentally input and output are very simple, on and off, zeros, ones. Yeah. So the concept of polar opposites is actually go back to far back, at least 5,000 years ago. In China, we have the concept of yin and yang, which is the polar opposite. That concept was developed throughout years into a kind of technology also, actually. It's been used for 5,000 years, for example, in Chinese medicine. Using this combination of those polar opposites, yin and yang, you can form elements like fire, water, air, earth, metal. And those elements actually composed of polar opposite, yin and yang. Yeah. And in 17th century, there was German missionary who actually translate this book into German. The book is called I Ching, the Book of Change. Leibniz saw this book and he came up with the binary system. So the binary system is originally very old concepts, very old philosophy, and based on the binary system, we have the yin and yang, we have zeros, ones, we have on and off. With modern electronics, we can actually make computers. So that's very important concept. Yeah, zeros, ones. Throughout the years, the computer has been developing very rapidly. At the beginning, it can only handle numbers. Yeah, like a calculator does now. But through programming, gradually it become more and more powerful. Nowadays, it can handle all sorts of things, not only text, images, but multimedia. A major development nowadays is virtual reality. Yeah. In near future, the virtual reality will be made as real as the reality itself. There's all the difference between the virtual reality and the real reality is the boundary is going to be blurred. Yeah, because technology is developing so fast. The virtual reality concept and computation concept make people think, actually. Some thinkers begin to think, oh, is our universe actually also possibly a virtual reality? Yeah, so people begin to think because there's concept tools we can use to think. The concept actually started in 60s. Konrad Zuse is a distinguished German scientist, computer scientist. He's one of the pioneers of computing. Actually, he developed the first programmable computer in 40s. So in 1969, he began to wondering, is the universe being computed? Yeah. No one seems to bother about this idea until 90s. John Wheeler is this distinguished physicist, and he began thinking the same way. And one of the very famous phrases he used is "it from bit." Yeah. All things physical are information, theoretical in origin. Yeah. So in the 90s, mainstream physicists began to think in a similar sort of approach. Edward Fredkin is an American computer scientist. He further speculated that computer may be in another place. Yeah, he called it other. Yeah, he think there might be a computer in another place which run the physics. So from 60 to nowadays, the concept of simulated reality has been populated mainly by popular media, actually. Yeah, there's a few books written by philosophers and scientists, but mainly the idea was sort of spread by films, typically Matrix. Yeah. So Matrix made the concept of a sort of simulated universe very popular. So many people know these concepts from the film.
What is life for Elon Musk?
As I get older, I find that question to be confusing or troubling. I think particularly when you see the advancement of something like video games. You know, like say 40 years ago, the most advanced video game would be like Pong, where you had like two rectangles and a dot. But now you can see a video game that's photorealistic and millions of people playing simultaneously, and you see where things are going with virtual reality. Then eventually those games will be indistinguishable from reality. They'll be so realistic you will not be able to tell the difference between that game and the reality as we know it. How do we know that that didn't happen in the past and that we're not in one of those games ourselves?
Tonight's topic is the universe a computer simulation? We've got some highly thoughtful, talented respected people to weigh in on this.
The more I learned about later on as a physicist, the more struck I was that when you get deep down under the hood about how nature works, how can I be sure that this mathematical reality isn't actually some kind of game or simulation?
In my research, I had found this very strange thing, error correcting codes. Error correcting codes are what make browsers work. So why were they in the equations that I was studying about quarks and leptons and supersymmetry? And that's what brought me to this very stark realization that I could no longer say that people like Max were crazy.
So you're saying as you dig deeper, you find computer code writ in the fabric of the cosmos.
Computer code, strings of bits of ones and zeros.
We seem to see a pattern forming over here. Our universe is pixelated. A matter isn't as real and as solid as we'd hope. Our reality can be shut down, and we are ultimately informational, virtual beings so comparable to a computer program that it isn't a big jump to accept that we are possibly, no, we are probably living in a computer simulation.
Sold a gun to a murderer so you can play video games?
Yeah, sure. I mean, if you spend all day shuffling words around, you can make anything sound bad, Morty. Here, check this out.
What the hell? Where am I?
55 years. Not bad, Morty.
Where's my wife?
Morty, you were just playing a game. It's called Roy. Snap out of it.
The guy who really started forcing scientists to take this a bit more seriously and gave this idea a bit more scientific street cred, I think, is Nick Bostrom, my fellow Swede, Nick Bostrom.
We are almost certainly living in a simulation. It's a little bit complex, but it's really not more complex than most educated people could probably get their heads around if they thought about it for half an hour, kind of, if they actually tried.
You know, there's this interesting argument by your colleague at Oxford, Nick Bostrom. He argues that the notion of a simulated universe, what do you think about that?
I can't see how you could refute it. I mean, I can't see how you would actually be sure that we're not.
If the simulation hypothesis is valid, then we open the door to eternal life and resurrection and things that formerly have been discussed in the realm of religion. And the reason is really quite simple, because as long as I have a computer that's not damaged, I can always rerun the program.
If you're not sure at the end of the night whether you're actually simulated or not, my advice to you is go out there and live really interesting lives and do unexpected things so the simulators don't get bored and shut you down.
There you go. Add new sim. Let's make him neat. He's going to be outgoing to be a celebrity, because I want him to be a celebrity, sure. Nice. Oh my god. That is freaking hilarious. What are you doing?
So you can see that the idea is getting more and more attention, is taken more and more seriously by mainstream scientists as well. However, from 1969 to now, although more and more people start to think about it, it's still a speculation. Yeah, it is purely a speculation. There's no sort of big development on it. To my mind, if you want to make the speculation into even a hypothesis, never mind the theory, you need to solve some fundamental problems. Problems like, where is the computer? Where does it come from? What's it made of? Yeah. How is it built? What are its properties? Yeah. When we buy a computer, we'll ask what's the memory, what's the speed, the CPU speed, what's the property? And of course, finally, the important question, who is the programmer? Theoretical framework I have been trying to develop is trying to solve those questions. Yeah. By solving those questions, we have sort of a a proper foundation to build a hypothesis, rational, maybe scientific also. The approach I adopted is actually fundamentally different from physics. Yeah, I don't think the physics will solve the problem. So my approach is actually start from consciousness. Consciousness as a starting point, as the most fundamental existence. And you build everything up from consciousness. Yeah. In physics, we try to derive consciousness from matter. Yeah. So I'm trying to do the opposite way. Yeah. Trying to derive matter from consciousness. Yeah. So I only have one premise, which is that exists consciousness. Because consciousness is a term which are used by different people meaning different things. I'm trying to avoid it because it causes a lot of confusion. I call it source mind. Yeah. The source mind is the fundamental reality that exists, yeah, as a fundamental property of the universe. The property of this consciousness is actually very difficult to describe. You actually cannot describe it. It's not comprehensible. So when people are talking about the consciousness, the source of everything, they usually talk negatively. You cannot see what it is because it's not an object which you can talk about. It is non-dual. If it's non-dual, it's not an object you can talk about. So what you can talk about is what is not. So people usually describe it as non-dual, no time, no space, no form, formless, and no thing. It's nothing. It's a void. It's in Buddhist term it's called emptiness. Yeah. So it's very difficult to describe, and you cannot describe it because it's not an object. However, if you want to build a model, you have to say something about it. You have to define it some way. So I come up with a working definition. I define the source mind, i.e. the consciousness, as the potential power, the power to conceive, i.e. to create and perceive, to make sense, to observe, and the power to be self-aware also. There's a sense of I. Yeah. And it's an abstract power. It's not in space-time. Yeah. It's metaphysical, it's abstract, but it's a power which can do those things. That's my definition. So it's kind of a tiered structure. From this power, you create existence, and existence become yin and yang, split up into polar opposites. Once you have polar opposites, you have zero ones, and with zeros ones, you can make data. Yeah, you can write program, and then you can build a machine. Yeah, as we said, the computer is basically a switch. There's two states on and off. So with those three elements, you can output anything you want. So in Chinese, Taoist term is called Tao gave birth to one, one gave birth to two, two gave birth to three, three gave birth to everything. 10,000 things. That's everything. Yeah. So that's basically a framework. I don't have time to go into very much details how this is sort of evolved, but I'll just briefly describe all the basic steps to derive this model. Yeah. So basically, you have a metaphysical computer, yeah, which sits beyond space-time, and processing output that computation is space-time and its contents. And not only contents, but the story within it. Yeah, everything is output of that metaphysical computer. That's the basic principle. So the first step is actually create existence. Yeah. Consciousness itself is empty, it's non-dual. So there's nothing. There's not even a concept of existence. And although it's conscious, but it cannot conscious of anything because nothing exists. Yeah. So the first thing it needs to do is to create something which it can be conscious of. So using computer terminology, it creates a screen. By creating a screen, it can project its power onto the screen. It's like looking at a mirror. Now it can actually make sense of itself. It can perceive itself. Before that, it cannot even perceive itself. So by projecting the power onto the screen, and the consciousness can now perceive itself. And I sort of I made it into a square, call it unity screen. It's a screen. That's the totality. All it has created. So nothing else is there. It's only a mirror, which it can reflect itself. So the content of the unity screen is the one pixel of project power of the source mind. Yeah. So nature of this pixel is one total, even, non-changing. Nothing changes. It's unchanging one. Although it creates something which exists, it's kind of boring. Nothing changes. So to create change, it creates polarity. So it split up the screen into two images, A and B. So if you combine the two images, it becomes the screen. Yeah. If you split up, it becomes image A and image B. So the parts which has projected power, we call it pixel. We call it 1. The parts which hasn't got projected power, which is a void, we call it 0. Yeah. Because by definition, the sort of a screen is the scope of the perception. It's a totality. There's nothing exists outside of it. So by splitting this up, two images, now the image A and B cannot be perceived at the same time. Now it has to be perceived in sequence, one after another. So this creates change. So it is kind of a loop. Yeah, in computer term, it becomes a loop. So at one half-time cycle, you have image A. The second half cycle, you have image B. Yeah. So I define another term called the present moment. The present moment is a temporal duration for one pixel void to switch one cycle. That's present moment. Yeah. The unity screen can be divided many times. So we just saw it divided one time. But each pixel can be divided further. So it depends how many times you divide. You have a number of cells which you can use to store 0 or 1, which is memory. And you have a different clock speed for different definition of different division of the unity screen. And you have a different value of present moment according to the definition. So if you divide it sufficient times, now you have a sufficient memory to create those 3 elements. And all the 3 elements are made of zeros, ones, as I described. So data, in this case, is actually metadata. It made of zeros, ones, and program you can written in binary, and the processor, which is the switch. Yeah. So with those 3 elements, you can output anything. So this is the basic framework. Yeah. Started with consciousness. Consciousness digitalizes itself. So it becomes zeros, ones, and with zeros, ones, you build a computer, you build a program. And by running this computer, you output universe. So I would like to emphasize this computer stays beyond space-time. So I call it Platonic computer. Yeah. So it's in a Platonic realm. It's not in physical realm. Yeah. So according to Plato, all that exists phenomenologically has an origin in Platonic realm. We have an apple here, physical apple. We actually have an appleness in Platonic realm, which is more real, more perfect. The physical existence is actually a poor copy of what's in the Platonic realm. So in this case, we have a computer which is more powerful, more perfect, in Platonic realm. Yeah. So it's kind of Neoplatonism model. Yeah. We'll discover with this model, it becomes very powerful tool to deal with many problems. For example, time. We cannot define time. Time was never able to be defined in physics. In physics, we just call it t. In physics, t is the same past and present, future. And past and future are symmetrical. It's just t. Obviously, we know that the present moment is very special, but physics cannot sort of explain why present moment is special. So in this case, the past is basically processed data. Yeah. The future is the data which yet to be processed. And the present moment is the moment when compute happens. Yeah. So here in the present moment, you have a switch, on-off switch, which does the computing. And you have the present moment, depends on how many divisions you have, and you have a clock speed. Yeah. So actually, the time is actually the simplest form of program. Yeah. It just basically alternate zeros, ones. Yeah. If you run this program, you get time. So it actually also explains why time is not reversible. Because computing is irreversible. the output cannot be reverted back to the input. No. Therefore, the past cannot go back to future. It's one way. Yeah, it is to do with the irreversibility of computation. So what is then space? Space is basically output of a computation. Yeah. So in this case, if you make a program like in a computer, you can actually output a space, which is a 3D space, which is actually made of pixels. Yeah. Those pixels actually is also the project power of consciousness. So you have a machine, and you can run a program, and you can make space. Yeah. Before you're making space, actually there isn't space. It's beyond the space. Okay. So by programming, you create a space, and this space is made of pixels, and it functions as a display, as a 3D display, which is made of pixels. With this space, you can output the content, which is the universe. So it's basically, in this model, we suggest this is a virtual reality. It's output of computation, and it's basically image. But people can argue, why is it so real? It looks physical, it feels physical. I can show you it's actually a trick. I don't know how many of you have never played computer game. How many of you never played computer game? Yeah. If you haven't, maybe you need to watch this video for a couple of minutes. Basically, image can be programmed to behave as a solid. Yeah. We measure things by interaction. Yeah. And the result of interaction actually can be programmed. So we can program this ball. When it hits the edge or hits the other ball, it obeys mechanics. Yeah. So make it appear as though it has a momentum, it has a mass, it obeys physics. Yeah. But it could be is actually a result of programming. Yeah. So programming is so powerful. It can make an image, solids, liquids, gas. For example, maybe this table is programmed which doesn't allow my hand to go through it. Yeah. So when my hand touches the table, I have to stop because it's programmed to behave like that. Give me a feedback. Oh, this is a solid. Does it make sense? Yeah.